CPU, Central Processing Unit. Beginner level. The CPU, Central Processing Unit, is the most important component of a computer. It is often called the brain of the computer because it performs calculations, logical operations, instruction execution, decision-making. Every program you run, every click you make, and every operation in a computer is handled by the CPU. Examples of CPU tasks include running applications, processing user input, performing calculations, controlling other hardware components. This topic helps beginners understand how the CPU works internally and why it is critical. It also introduces key concepts such as instruction processing ALU, arithmetic logic unit, control unit, registers, clock speed. CPU, Central Processing Unit, is the part of a computer that executes instructions and processes data. In simple words, CPU equals the brain that controls and processes everything in a computer. A beginner view includes fetching instructions, decoding instructions, executing operations, producing results. Why CPU is important. The CPU controls all operations in a computer. It is responsible for running programs, performing calculations, managing system operations, coordinating hardware components, processing data. Without CPU, no program can run, no data can be processed, the computer cannot function. CPU overview, component purpose. ALU performs arithmetic and logic operations. Control unit directs operations. Registers stores small data temporarily. Cache, fast memory inside CPU. The CPU consists of several internal components. 1. ALU, arithmetic logic unit, performs calculations, addition, subtraction, handles logical operations, and, or, not. 2. Control unit, CU, controls execution of instructions, directs data flow between components. Registers, small, fast memory inside CPU, stores temporary data. Example of CPU representation. CPU equals ALU, calculations, control unit, instruction control, registers, temporary storage. How CPU works, instruction cycle. Step 1, fetch. CPU fetches instruction from memory. Instruction equals add D. Step 2, decode. CPU understands the instruction. Operation equals instruction. Step 3, execute. CPU performs the operation. Result equals 5 plus 3. Step 4, store. Result is stored back in memory. Memory equals result. Simple instruction cycle example. A equals 10, B equals 5. Fetch and decode operation equals add. Execute if operation equals add. Result equals A plus B. Store, print, result. Result. CPU and clock speed. Clock speed determines how fast the CPU works. Measured in gigahertz. Higher clock speed means more instructions per second. Example, operations per second equals 3 billion billion, hashtag 3 gigahertz CPU cores. Modern CPUs have multiple cores. Each core can process tasks independently. Types: single core, dual core, quad core, multi-core. Example: cores equals 4. Tasks equals task 1, task 2, task 3, task 4. Cache memory. Cache is fast memory inside CPU. Levels: L1 fastest, L2, L3. Purpose: speeds up data access, speeds up delay. CPU in action. Simple example: number equals 7. If number %2 equals 0, print even number, else print odd number. CPU performs this logic. Full menu-based CPU simulation, Python. Def add, A equals input, enter first number. B equals input, enter second number. Print result, A plus B. Def check even. Num equals int input, enter number. If num %2 equals 0, print even. Else, print odd. While true, print N1 add numbers. Print 2 check even odd, print. 3. Exit. Choice equals input. Enter choice. If choice equals 1, add. Elif choice equals 2, check even. Elif choice equals 3, break. Else, print invalid choice. Concepts learned from CPU. Instruction execution cycle. Role of ALU and control unit. Importance of registers and cache. CPU performance factors, multi-core processing. Real-life analogy. CPU is like a chef in a kitchen. Instructions means recipes. Ingredients means data. Cooking means processing. Final dish means output. Ways to improve CPU knowledge. Learn assembly language basics. Study CPU pipelines. Explore multi-threading. Compare different processors. Learn about GPU versus CPU. Study performance optimization. Common mistakes beginners make. Thinking CPU works alone. Ignoring memory and cache. Confusing cores with speed. Not understanding instruction cycle. Overlooking heat and power limits. Where CPU is used. CPU is used in computers and laptops, smartphones, servers, gaming consoles, embedded systems, IoT devices. Simple definition. CPU, Central Processing Unit, the component of a computer that processes instructions and performs calculations. Final summary. The CPU is the heart and brain of a computer system. It enables check. Program execution, check. Data processing, check. Logical operations, system control. Understanding the CPU helps you learn how computers actually think and work.